I'm not sure what just happened there. I don't know if I ended my video and I'm restarting or what, but okay. So I got some worksheets. Remember, we practiced finding ratios. Using SOHCAHTOA. We evaluated using our calculator, making sure our calculator is in degrees. Finding side lengths. We use Pythagorean theorem. And then remember when we're finding angle measurements, we're using the inverses. Okay, so when you're solving a right triangle, it's got to be like the best right triangle that I've ever drawn freehand. Remember, capital letters are for angles. So those are all my capital letters. This here would be my right angle, okay, which makes this side always, always, always the hypotenuse. But here's something else that you need to know. Your angle, the side opposite the angle is the corresponding side. So what the heck did I just say? Well, if this is angle A, then this makes this side A, and I'm going to use a lowercase for that. Okay. If this is angle B, that makes this lowercase side B. And then if this is angle C, that makes this lowercase side C. Okay. So remember that your lower cases are your sides. Oh, for crying out loud, you know. And that your upper cases are your angles. I'm running off of coffee, so the side opposite the angle is the corresponding side. When you are solving a right triangle, you must know all angles and side measurements. I can fit it, I can fit it, I can fit it, I can fit it. Can't fit it. Okay, so I'm going to know all angles and side measurements when I'm solving a right triangle. I'm not even sure how that even came up or how I get rid of it now. I need this to go away. Go away. Okay, anywho. So let's practice. Let's just do this. And I learned from my last video that I'm not just going to make up problems off the top of my head. That's embarrassing. So here I have this triangle. They're going to give you just enough information. Just enough information to leave you hanging. Okay. So here's the first thing I do to set it up. Okay. I'm dealing with angle X, angle Y, and angle Z. Okay, so I'm going to set up my little solving thing here. So I know that I'm going to need, you don't have to do this every time, but I'm just going to do this. So I'm going to have angle X, angle Y, angle Z. What? Can you wait till I'm done with this video? I asked you before, so you can either grab a muffin, grab some donuts. Now I'm making a video, you're going to have to wait for me to be done. Okay, grab something for the time being, which means that I'm going to have side x, side y, or side z. Okay. Does it give me some units here? We'll just say that this is feet. So all of my angle measurements, my units are going to be in degrees, and all of my side measurements are going to be in feet. Got to make sure we have the unit, right, Briar, or the crazy math lady will mark it wrong. So if this is angle Z, that makes this side Z. This is angle Y, so that's side Y. This is angle X, so this is side X. So now let's fill in what I already know, right? I know that angle Y is 21 degrees. Okay, so I can fill that in right now. All right, and I know that angle Z is what? Right, angle Z is 90 degrees. And I also know that side X is 6.4 feet. Okay, so now I have to find these three pieces of information here. I got to know what this angle is and then these two sides are. So the easiest place to start, right, is I have this triangle. I have two measurements. So to find my missing angle here, I can just take 180 and subtract these two. Okay, so I know that 180 minus 90 minus 21 gives me a difference of 69 degrees. So this is 69 degrees here. Now, to find your side measurements, to find my side measurements, I can use a trigonomic ratio. Okay, so let's say I want to find side y. If I want to find side y, I can pick a reference angle. Okay, so I'm going to pick my theta, and let's just say I want to use this 21 degrees here. So I'm going to use, this is my theta, and to find side y, well, this would be the opposite, right? But in order to use a trigonomic ratio to find an unknown side length, then I have to know at least one side, which I do, which is my adjacent side. So if I'm going to be dealing with the opposite and the adjacent side to find an unknown side length, well, then I'm going to be using my tangent function, because remember, SOHCAHTOA, the tangent function is the opposite over adjacent. So the tangent of 21 degrees equals the opposite over my adjacent. All right. Well, now I just have a one-step equation. Here's my variable. To solve for that, I'm going to multiply both sides by 6.4. That's going to cancel. So what I type in the calculator is 6.4 tangent 21 and then enter. So 6.4 tangent 21 equals, and I'm going to get approximately 2.46 feet, right? Because I'm rounding to the nearest hundredth once I type that into my calculator. Well, I would rather not use Pythagorean theorem, so I can use a trigonomic ratio to find side Z, right? So I could still use 21 as my reference angle. But now let's say, let me erase these I shouldn't have erased those. This is my opposite side, this is my adjacent side. Now I'm finding my hypotenuse. So if 21 is my reference angle, I could either use the opposite over hypotenuse or the adjacent over hypotenuse. So I'm going to pick that the sine of my 21 degree angle, right? So the sine of my 21 degree angle is going to equal my opposite, which I found to be 2.46. I should have wrote that in there, over my hypotenuse. Well, now my variable is in the denominator. Whatever will I do? Well, I'm just going to flip-flop, okay? What is she talking about, flip-flop? I'm going to take and I'm going to change the spots of these two things. So what I will have is h equals 2.46 divided by the sine of 21. So I'm going to type that into the calculator. 2.46 divided by the sine of 21, close, and I get approximately 6.86 feet. All right. Let's do it. I have all my measurements. I got all my degrees, all my side measurements, so my triangle is now solved. Let's do one more example. Here's my right angle. 12, 8, and we'll say that this is A, B, C. Okay, so now it has a little bit less information, right? I only know 2 side lengths. So I'm going to solve for my 3 angles. And I'm going to solve for my 3 sides. Well, I already know that side B is 8. Oh, I forgot my units again. We'll say centimeters this time. And how did I know that side B was 8? Because 8 is opposite angle B. And then side A is 12 centimeters. So now this one I have to find my 3rd side length, which is my hypotenuse, which means I'm going to have to use Pythagorean theorem. Not happy about it, but it is what it is. So Pythagorean theorem says a squared plus b squared equals c squared. I can plug 8 and 2 in for my legs. Why? Because 8 and 12 make, I just said 8 and 2, 8 and 12, because they make up my right angle here. So if they make up your right angle, they are the legs, right? So 8 squared plus 12 squared equals c squared. I'm going to have 64 plus 144 equals c squared. So c squared equals 208. We got to take the root of both sides. So c equals, now let's break it down into prime numbers. I have 2 times 2. I could just keep dividing this sucker by 2. By 2 times 2 times 13. Okay. So 16 times 13 gives me 208. Perfect. I've got how many married couples here? 1 married couple, 2 married couples. So that comes out as C. Oh boy, not in red. I hate red. C equals 2 times 2 is 4 square roots of 13. Okay, so I'm going to, let's write that in. 4 square roots of 13 here. 4 square roots of 13 here. I will be darned if I'm ever going to use this in any of the trig ratios to find the angle measurements. Just saying, I don't want to use an irrational number. I'm going to kind of stick with these 2 nice numbers that I have here. Okay, so now I'm going to I have to find angle measurements, right? And referring back to my notes, if I'm finding angle measurements, that means that I'm going to be using my inverse trig functions. Okay, so I'm either going to have to use the inverse of sine, the inverse of cosine, or the inverse of tangent. Remember, the sine is the ratio of opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I need to find the measurement of angle A, okay, all right, this is going to be my reference angle right here. If I need to find this measurement angle, and I only want to deal with the 12 and the 8 because those are nice, pretty numbers. 12 is my opposite, 8 is my adjacent. So if I'm dealing with the opposite and the adjacent, I'm going to use the tangent function. So the inverse tangent function is going to equal the ratio of 12 divided by 8. So I can go ahead and plug that into my calculator, second tangent, and I'm going to say 12 divided by 8, close the parentheses. And I'm going to see that that angle measurement right there is approximately 56.31 degrees. Right? Now, I neglected, I know that angle C is 90. To find the measurement of angle B, I'm just going to have to subtract 90 from 56.31 to get that the measurement of angle B is 33.69 degrees. Okay, so solving right triangles, there's multiple steps involved. You're going to have to use trig ratios. You're going to have to sometimes use Pythagorean theorem, and you're going to have to know that remember that the inside angles of a triangle add up to 180 degrees. You are going to have a worksheet to practice this, and let me know if you need me.